So it's my honor to be able to introduce Lisa Schulke-Moore. Before I do that, we do need to remind people that there is a social immediately following this talk. It's at Tom Edwards House. Juniper Drive is just this way. There's directions over here, pretty close to here. Roughly 800 north and 1300, 1350, 1400 east. Pretty easy to find from here. It'd be walking distance, it was safe to walk that far. Other than that, so let me tell you a little bit about Lisa, not too much because she's from the Midwest, and so long introduction's embarrassing.
Totally embarrassing.
But Lisa is a faculty member in Natural Resource Ecology and Management at Iowa State University, where she's been for
12 and a half
12
years.
years, yes. And she's got a doctorate in forestry from the University of Minnesota, and she teaches forestry classes at Iowa State, but her research grows considerably beyond that. In fact, that's one of the things that really impresses me about Lisa's work is not only she's very productive, but she's productive in a bunch of different areas. So if you look at her CV, there's articles about agriculture conservation policy and about biodiversity conservation and productivity and energy plots and all kinds of different kinds of factors, all of which have to do with doing sustainable land management as social ecological system lens. She also works at multiple scales, and particularly at the landscape scale, which is, again, something fairly unique in agroecology and ecosystems work. So with that, I'll invite Lisa to come and I'll shut up.
Great. Thanks, Mark. And you got that.
Let's try this.
Okay, sounds good. And I'm mic'd, but it's for that. So I hope that you can hear me all okay if I speak at this level. Is that okay? Okay, great. And thanks for the the Ecology Center for sponsoring my visit, and for Gwender and Dave for arranging my schedule so nicely. I had wonderful chats all day, and I'm looking forward to tomorrow as well. Thanks for coming out tonight for my talk, Tweak, Adapt, Transform, Growing a Resilient Agriculture in Iowa and Beyond. More than anything, this is a story about teamwork. I work in, what enables me to do the kinds of work that Mark just talked about is I work in big interdisciplinary teams. And so even though I get to be here with you tonight and present this cool research, realize that it's the work of many. And if I were to put all their names on the slides, it would be impossible to fit them there. Here's some of them, as well as the funders that fund the work. And in this work, this is the really big question that we're trying to address. How do we feed a growing population without destroying the planet? So we're at 7 billion people on the planet today. UN suggests that we're headed towards 9 to 10 billion. All these people are putting pressure on our agricultural systems, our ecosystems. We're adding biofuels to the mix to try to produce renewable energy. In terms of the food that we consume, we're eating more and more animal products, which means the energy efficiency of our food production is going down. All of this is putting a stress on the planet. And actually, if you look at our big, beautiful planet from space, there's actually nothing that forms a more dominant signature on that planet than agriculture. And our crop systems today that we grow for human and animal consumption, it covers about 6 million square miles today. And to put that in perspective, it's an area about the size of South America. Add to that rangelands, which Mark studies, and probably others of you in here as well. That's about 12 million square miles covering the planet, and that's an area about the size of South America. So the signature of our agriculture is huge. And when we think about things like biodiversity conservation, nothing has had a greater impact on biodiversity than agriculture. Certainly the leading cause of conversion of our native ecosystems historically and even into today with conversion of rainforests, as you see here. But still we're doing it in very settled places like the Midwest where I'm from, where we're converting, in this case, a native savanna to grow more corn and soybeans. In Minnesota, we have some of the fastest forest conversion rates in our nation right now. We're converting pine forests to grow potatoes. And so there's lots of loss of our native ecosystems and the biodiversity that go along with that to support it. And certainly when it's not just on land, these impacts, but it's also affecting our ocean systems. Downstream from the Great Corn Belt, we have the hypoxic zone in the Gulf of Mexico, the dead zone, where anoxic conditions and cannot support aquatic life anymore. And certainly as you look across the globe at any of the major agricultural production regions, you see that same signature of hypoxic zones downstream from these areas. And maybe you care more about climate than these other things. Certainly about a third of the greenhouse gas emissions through time have been associated with agriculture, mostly because of that land use conversion, but also because of methane production associated with animal agriculture and nitrous oxide emissions associated with crop agriculture. So huge impact on our climate systems, and certainly also has an impact on our soils, which are the foundation of agriculture itself. UN estimates that about 1/3 of our soil systems are severely degraded. So that really challenges our ability to produce food for generations in going into the future. And this is a picture from just outside of where I live in Ames, Iowa. So agriculture, we need it. It's the foundation of our civilization. We're not going to grow enough food to produce. We're not going to produce enough food to feed us in any other way. But we need to figure out how to solve some of these really critical challenges so that we can have an agriculture that meets 21st century demands on our planet. And we all need to eat, right? I'm a mom of 2 young kids, and I know that we get really grumpy when we don't get enough to eat. And so this also has ramifications for our societal happiness and political unrest in different parts of the world. So we need agriculture. The question is, how are we going to go about our agriculture? And that's really the question that I'm trying to help folks in Iowa. My teams are trying to create a dialogue to figure out how we're going to create an agriculture that does meet our current challenges and moves us forward in a way that's more sustainable. In order to do that, we need everybody at the table. So we've been around sort of the boardroom table, we've been around the meeting tables, but now we need to gather everyone to the supper table and have these conversations about food and agriculture around the supper table and how we're going to do this. In terms of, I'm trying to do that here in Iowa, and whenever I leave Iowa, I have to point out where we are and make sure you know that we're not Idaho, but we're also not Ohio, right? So that's the place where I'm working, and is going to be the story that I share with you today. And in Iowa, agriculture is our culture, right? We're first in the nation in soybean production, oftentimes first in the nation in soybean production, although sometimes, Illinois ekes us out, first in the nation in hog, egg, and ethanol production. And it's a fact that the state is really proud of, and we want to maintain that. It's about 20% of our economy, and over $30 billion per year in terms of overall economic revenue generated. Really important to the people of Iowa, but at the same time, over 600 of our state's waterways are considered impaired under the Clean Water Act. Our major metropolitan area, Des Moines, is now suing upstream. Their waterworks which supplies clean water for about 1/6 of the state's population, is now suing upstream counties over water impairment to drinking water. About a third of the species in the state are estimated to not make it to the next century unless we have active management of their populations. So we're proud of agriculture, but we also know that there's certain challenges that we need to move beyond. So the outline of my talk today, I'm going to talk about what the future of agriculture is, envisioning that future, bringing stakeholders together to envision that, fostering change in terms of 3 projects that address tweaks in our agricultural systems, adaptation and transformation. And then based on this research, how do we go about scaling it up to have a more meaningful impact over landscapes? And then I hope to engage you in thinking about what you can do to also move us forward towards a more sustainable agriculture. So first of all, envisioning the future. I talked a little bit about bringing people to the table. The groups that I'm trying to bring to the table to have this discussion in Iowa are, of course, the farmers. They're the people that are closest to the land and growing our crops and raising our livestock. And then also the commodity interests that represent farmers in the state, groups like the Iowa Soybean Association, corn growers, and also representing agricultural industries, some of the environmental groups, such as the Nature Conservancies, Trees Forever, active in the state, as well as governmental agencies, such as the U.S. Natural Resource Conservation Service and the Iowa Department of Ag and Land Stewardship. And we brought people together for a discussion about what do you expect in terms of the future of agriculture, what should it produce in Iowa. And the process has started with actually interviewing farmers, in-depth interviews to find out what their challenges were on their farms. Focus groups with representatives of these agencies, which I call regional change agents. Sometimes they're farmers, sometimes they're representatives of organizations, but they certainly have the ability to advocate for change in agricultural systems at a state and federal policy level. The development of alternative scenarios for the future, and then going and visualizing what those scenarios would look like on the land, and then following that up with both interviews with the farmers and the regional change agents. And here is the good news, is that there's a lot of consensus about the future, regardless of which group that you're talking about. And in general, the vision for the future is, we're Iowa, agriculture is our culture. We're going to continue to keep that moving forward. We're going to continue to grow and raise agricultural products. But moving forward, we recognize that we need to do a better job of also producing environmental benefits from these agricultural lands to satisfy the farmers themselves, but also the urban populations within the state as well as downstream. In terms of strategies, there's also a lot of agreement that we need more landscape planning. So instead of sort of random acts of conservation, we need to be more strategic about our efforts. And also we need more cross-boundary partnerships. So things like commodity groups working with environmental groups, working with farmers. And also cross-ownership boundary partnerships with farmers working with their neighbors next door. And thirdly, in terms of what happens on the ground, how does agriculture change on the ground, there's also a lot of agreement in the tactics. So one of the areas of improvement is improved management of the crops themselves. So if anybody's ever heard of the 4R strategy in terms of nutrient management, putting the right fertilizer on the right place at the right time and the right amount. So improving our management of the crops, but then also, or changing the tillage of within the cropping system. But also this idea that we need to take our annually based landscape, dominated by corn and soybean, that are annual plants, only active for about 4 months of the year on the landscape. The rest of the year, most of the about 26,000 acres of Iowa is bare soil. We need to integrate in perennial plant communities into that annual landscape to provide more conservation benefits. So this is the really great news. Everybody agrees that on this overall vision, and then how we actually get there. But oftentimes in group processes, it's really easy to agree on the broad goals. We all want clean water. We all want profitable farms. We want vibrant rural communities. That's easy. The hard stuff is down here, like how do you actually go about this on the land? And so in order to try to figure that out, a graduate student of mine, Drake Larson, a few years ago, developed some visualizations to really foster that conversation about how are we going to do this on real places. However, when you start talking about real places, people kind of get twitchy because, of course, you can't make changes to your farm, or you don't want to suggest you would make changes to Bob's farm. And so he created these visualizations, computer-generated visualizations, to try to foster conversations about how we would go about this. And in this particular case, we were really looking at this idea of putting more perennial vegetation within the annual crop matrix. And so what you see here is a fictional watershed. It's generated in computer space. It's got corn and soybean on it, and it has a stream running through it. And in this case, the stream is buffered with perennial grasses, in this case prairie. And those perennial grasses make up 2% of this foreground of the watershed. So 2%. Drake then visualized the same watershed with more and more perennial plant communities integrated in ways that made sense based on what farmers told us they would be willing to do on their farms. And so I'll play a little animation that shows you what a watershed could look like with more perennial plant communities integrated in very strategic ways. And so here we go, a 4% perennial landscape, 8%. 16%, 32% perennial, and then 64% perennial. I'm going to play that back again, and I'll explain a little bit more about what you're looking at here. So I described the annual landscape with just 2% along that riparian area in the perennial plants. Realize this is a little bit different than what we have in Iowa right now because we don't have all of our streams buffered right now. In many cases, the crops just go up to the stream. So this is a change from sort of normal practices. And so with 4%, we would add a nutrient removal wetland. With 8, we have a variable width buffer instead of uniform width. With 16, another variable width buffer, and you get more nutrient removal wetlands. We start adding bioenergy plantations up in the upper portions of the watershed, bioenergy plantations in terms of switchgrass here, and then rotational grazing at the 64%. So we brought these to people, representatives and organizations, farmers, other scientists, and we asked them, what they thought. And we're interested in two things. One, when they viewed these, what environmental benefits did they expect that these landscapes would provide? And then secondly, at what point were the landscapes balanced in terms of the agricultural production and then the production of environmental benefits? At what point were we balanced in terms of basically what there are markets for now and what there weren't? And here's what people had to say. This particular quote, and it applies to both the 2 and the 4% perennial, was offered by an agronomist. And he said, these two scenarios offer very little beyond production value. In fact, it's so skewed towards production that even the production benefits are likely compromised, even in the long term. So that suggests that, we can't even keep doing the agriculture like this long into the future if this is the way we're going to arrange our landscapes. And just about everybody that we talked with said this is what Iowa looks like now. And if you've ever driven through the Midwestern states in the summertime, you will know this because that's what you see in many places. On the other end of the spectrum, people said, they would look really closely at the visualizations and they'd say, that's where I'd put my house. And to me what that's saying is, in the one case we have a landscape that's a working landscape. It's where people go to work, produce their crops. But here, we're really getting into some other conceptions about what people want from landscapes. And basically what they're saying is that this landscape is not only, where they might want to work, but where they'd want to live and play, right? So it's fundamentally, they're conceiving this landscape in a very different way. But they also said, and this was in particular, the commodity farmers in the group, was definitely last. There's nothing for me here. So even though the majority of people, they like the way this landscape works, it doesn't work for the people that are working the land today. So there's a disjunct. As we pooled all of the data together, we started to see this emerging pattern around 16% landscape, 16% annual, and then the 84% in the annual row crops in this case. And what people were saying was just, if they were coming at it from a farming side, yeah, it's going to be harder for me to move my equipment around and such. But, I think if we just shaved off this edge here, I could make it work. Or, if there were certain policies that helped pay for this wider buffer, I could see doing that. And as you talk to people coming at it from more of an environmental side, they would try to push it up. They're like, oh, I really like the 32% landscape, but, I recognize that's a really heavy lift, so I'd be okay with 16, right? It would be a lot better than what we have right now. And so what we're seeing emerge is that this is kind of a consensus landscape. It's different than what we have now, but people could really see how we could get to such a landscape in the not too distant future. And I like this quote that kind of sums up what people said, and it was offered by someone who worked from a commodity organization, who said, targeting practices to the critical areas, the areas where they're going to have the biggest benefit, will accumulate the benefits better. We're going to use natural systems in addition to engineered systems, and we're going to create a diversity. We'll have a balance of approaches and benefits. And so that's really what people were thinking of when we asked them overall to articulate a balanced landscape. It's something with 16% perennials strategically integrated in. I've since kind of binned these into 3 different categories. A tweak category, which isn't very much of a change on what we have right now. We're just adding a little bit more perennials in, and we're really strategic about where we put them. And the second one, that more consensus landscape for where we could go, an adapt landscape. Farmers would have to change the way that they're operating the lands, but it's potentially doable if we align the system right, especially if we start rewarding farmers for producing more environmental services in addition to just crops. And then this last one, 50% landscape I call transform. In order to get here, we would need to, overall, basically our whole agricultural systems. The markets, the infrastructure, the policies, everything would need to change to actually create a landscape that looked like this. So it's transformative. And even though I pit these against each other as sort of alternatives, in reality, all 3 of these are happening in the Iowa landscape in different geographies. In geographies where, for the farmers working the land, they make sense. And I'm going to tell you now about a series of projects that I'm involved with, looking at tweaks, looking at adaptation, looking at transformation in different parts of the Iowa landscape. And the first of them is fostering tweaks using public-private partnerships in the Boone River watershed. And this project is led up primarily by the Iowa Soybean Association, as well as partnering with the Nature Conservancy, NRCS, and then also farmers in the watershed. And really key piece of this is water quality monitoring. One of the things that folks realize is that we know that we have a water quality problem, but we don't necessarily know when it becomes a problem, where are the source areas, and which management practices do the best job of fixing the problem. And so in this case, a group of agricultural retailers, which called themselves the Agriculture's Clean Water Alliance, taxed themselves to pay for monitoring within both the Boone and Raccoon River watershed, because if we're going to implement solutions and we're going to pay for them, we want to know that they work, right? And so monitoring is a really critical piece to knowing what works. They funded really depth water quality monitoring within the Boone River, and it's now the best water quality monitoring data we have throughout Iowa. Is funded by this agricultural organization, which I think is really cool and forward-looking. They're also helping farmers to adopt emerging technologies, offsetting some of the costs associated with adopting these technologies. And in this case, what we see is there's a bioreactor being installed on the edge of a field, of a corn or soybean field in Iowa. And it basically is going to divert some of the tile water flowing from underneath that farm field into a trench that has wood chips in it. And the microbes in that trench are going to use the carbon from the wood chips, and they're going to take the nitrogen out of the water, and they're going to use it to grow their communities, and so then we have less of a water quality problem. And so it's an edge-of-field practice, highly technological, that addresses water quality. And farmers don't need to change anything about what they're doing because it's an edge-of-field practice. Agriculture's Clean Water Alliance is offsetting some of those costs. And then getting farmers to talk to one another. We have some early adopters that are changing their tillage practices, changing their nutrient management. They might be adopting cover crops. Some people are more willing to change and experiment than others. And what we're doing here is getting the innovators and early adopters to talk to their neighbors about what's working, why, get the kinks out of the system, and lower the barriers so that more farmers can adopt these practices. And so it's not changing a lot in this case, but we have vibrant discussions about how to move Iowa agriculture forward. And this region the Boone is in is the most profitable area for producing crops in Iowa. So any kind of change is, in many ways, it costs a lot. So tweaks make sense in this landscape. And here is just one example of a quote from a farmer in this watershed who is benefiting from it. One of the other things that farmers said that they loved about this project is they're getting personalized data from their farm. And they're using personalized environmental data to then change how they were producing their crops so that they would have less of a negative impact, and in this case on water quality. The second project I offer is the Prairie Strips project. And in this case, we're adapting the corn and soybean system that we're working in. And the way that we're adapting it is we're using prairie, which is Iowa's native ecosystem. It was what was there after the Ice Age and prior to European colonization. Diverse perennial plant communities. It's well adapted to Iowa soils. It's well adapted to our climate. Our native biota are adapted to prairie, and we're actually sowing prairie in corn and soybean fields. And one of our prairie strips at our initial experimental area, it looks like this, where it's, you've got prairie growing right next to corn. And we're also implementing really in-depth monitoring. In this case, you see one of our catchments where we've implemented a 10% prairie strip solution. So the dark green looks like soy in this case, and then the lighter green are the prairie plants that we sowed. Some of it at the base of the catchment, and then more on the contour, so it slows water down as it's moving across that hill slope. And in this case, we can collect any water that runs off that watershed, so we know what kind of impact the prairie plants are having on water quality coming off of that watershed. We've also looked at groundwater quality, we've looked at birds, the plants themselves, we've looked at insects, we've looked at all sorts of nutrient cycling within the soils to really try to get a sense of what's happening in these agricultural catchments. And then we compare it to our control, which is what is usually done, all corn, soybean agriculture without any kind of native prairie integrated. Why prairie? prairies provide function. This is very much a functional ecological experiment where we're taking advantage of the diversity the prairie offers, the fact that it's native, the fact that perennial plants have dense root systems that go deep, and stiff upright stems that impede the flow of water. So that's why we're choosing prairie in this case. And a little bit about our results. Here's probably our most impactful data point in these 3 slides. They were pictures taken in 2008, June 2008, after a 4-inch rainfall, rain event that fell in a very short period of time. And you can see this is one of our control catchments. It's in corn this year using no-till soil management, and you lose a lot of soil. Compare that with, a 10% prairie strip solution. You can see in the water there's a lot less soil moving with that water. And this is another area nearby that's all prairie, and you can see the functions that prairie provides, nice clean water. So this is one event, but we've seen the same general pattern repeatedly over 10 years now. And the numbers that go along with this is when you put 10% prairie in, when you go from here to here, we see that we keep 95% more soil up in that catchment. We don't lose it to other, the downstream ecosystem. We keep 90% more phosphorus and 84% more nitrogen. For farmers, that's money in the bank. They paid for that nitrogen and phosphorus. They don't want to lose it if they don't have to. So keeping it up in the field is, a big benefit to them. And then we also see of overall overland flow reduction of about 42%. So 42% more of the water we're keeping up there. It's fueling the prairie plants. It's going back up into the atmosphere rather than leaving as runoff. We've also looked at groundwater, and we see that we improve nitrate, a key pollutant in the groundwater, by 70% when we add the 10% prairie strips. So take a little bit of land out of the corn and soy and put it into prairie, and you get these really dramatic improvements in environmental performance. We've also looked at some of the biodiversity. We see a 4-fold increase in native plant biodiversity. No surprise there, we planted them, right? But our native biodiversity are responding to that. We see about double the diversity in terms of insects, many of them beneficial insects, either pollinators or natural enemies that feed on potential crop pests, and then double the diversity or the abundance and richness of native birds, including a few species of conservation concerns, such as the dickcissels you see here perched on corn right next to our prairie. So we think these numbers are pretty exciting. The other thing that we've been able to show is that we don't create a weed problem for the farmers by putting these prairie plants in their fields. There's still weeds out there, but they're not the prairie plants. They're the annual weeds that farmers fight everywhere. And in terms of potential conservation practices a farmer might adopt, this is one of the cheaper ones. It's a lot cheaper than terraces. It's comparable to cover crop, but it's not an annual cost. So for many of the farmers that we're working with now, they say they see this as a practical option for their farms, which is exciting. And I'm just going to tell you a little bit about some of these farmers. This is Seth Watkins. He's our first adopter. He's really excited about the prairie strips and in general about sustainable agriculture. In addition to being a crop and livestock farmer, he's also a sailor, and he likes to spend vacation time down in the Gulf. And so when he goes to the Gulf, he wants to tell the people, the communities of people that he's interacting with, that he's a part of the solution and not the problem. And so we're giving him data to help him make that case. And then there's Gary, who's really passionate about soil. He spent time in the Peace Corps in Central America and has seen the what devastation soil loss and poor soils can cause on human communities. And he shared with me in an email earlier in December that with the addition of prairie strips on his farm, he's also converted to no-till. He's started adopting cover crops. He said for the first time in his life, he feels proud of what he's doing on his farm. So sort of that internal peace of mind that he's receiving, I think, is priceless. And then there's Tim, who, here's my field crew. He has a prairie strip just establishing on his farm. We planted it last spring, and he was kind enough to let us plant milkweed for monarchs on his farm as well. His neighbor came up and said, "Milkweeds? Didn't you get paid as a kid to get rid of those? Now you're planting them?" Right? But he's really interested in trying to support, water quality, but then support our native biota. Monarch butterflies are now in a precipitous decline in our region, the migrating population. And he shared this quote with me that it took me a while to kind of understand, but he says, prairie strips for him are conservation with a purpose. And to understand this, you really have to kind of understand the history of agricultural policy. Historically, after the Dust Bowl and into the 40s and 50s, farmers were paid to set aside some of their land under conservation, but the real goal of it was just the control of the amount of, it was control of the amount of product being produced, right? We wanted to take some corn and soybean off the market to raise the overall price. For a farmer who, their overall, goal and mission is to produce, to take acreage out of production, it's a loss. But what he's trying to say here is with all the benefits that we've shown with prairie strips, it's not a loss by taking this acreage out. Instead of producing corn and soy on that land, he's producing better soil, he's producing clean water, he's producing more monarch butterflies, and in his case, he's got some other really cool species of greatest conservation need, upland sandpipers and prairie skinks on his land, so he's producing a lot more wildlife. So it's not a net loss, it's a net gain in his mind. It's conservation with a purpose. He's still producing. Here are the farms that we're now working on. Here is our initial research site. We're working on 25 farms across Iowa and northern Missouri, and we've established about 180 acres of prairie strips, treating over 2,000 acres of corn and soybean land, and the phone keeps ringing. Farmers are lining up to adopt this practice, which is really exciting to be a part of. The last one is that transformation piece. What do we do to foster even greater change? And there's two projects that address this. First was the Landscape Biomass Project. The whole idea with this is in the late 2000s, both the US and the European Union, we had a lot of policies that were geared towards producing biofuels. Almost all of the money and attention went into producing biofuels from monocultures. And in many cases, what we did in the Midwest is we just doubled down on our corn production. And certainly from the standpoint of impact on corn supply, this is a percent of total corn supply in the U.S. that has gone to ethanol production. Some of it is still the DDGs that come off the process is also used for food, so it's not simply a trade for food for fuel, but you can see that it rose to about 40% nationally of the corn that we're using for ethanol production. If we're talking about energy, it could be other things that we use to produce energy other than corn. And the idea with the Landscape Biomass Project is what other systems make sense for this region of the world in terms of integrating into farmers' practices that could also be used to produce fuel, but then in addition produce greater environmental benefits. And here's some of our research plots. What you can't see so well here is that they're arranged over a topo slope. Most agronomic research, it takes place on really flat ground with very little variation in soil quality. What we wanted to get at here was we wanted great variation in the soil, because our idea is that we want to fit these into the landscape in ways that are profitable and make sense to the farmer. And some locations are less profitable for corn and soybean farming than others, but we need to understand that comparison. So it's a landscape biomass because we're looking at a topo sequence. And we've learned some really cool things. One of our systems was to establish the perennial switchgrass, and we did that under a corn crop. We used corn as a nurse crop, basically, to provide weed control and then offset some of the costs associated with establishing a perennial crop that takes a couple years to get going. What we've done here is shown that this practice is highly viable, and it's now sort of the way that people are using to establish switchgrass in the Midwest. We sort of tried the system out, and it's making sense, and people, this is like the standard way of doing this now. Also, because I am a forester, I was really interested in tree systems. Here we have a hybrid aspen system. In general, again, with that establishing a perennial system, it takes many years to do that. How do we offset some of those costs? In this case, we're growing the aspen further apart, and we're establishing triticale as a crop in between. So it's an intercropping system. You can harvest the triticale for energy or forage, offsetting some of the costs associated with establishing a tree system over a 4 or 5 year period. We've also done some really cool basic science, just comparing some of these annual and perennial systems across, again, a heterogeneous gradient, across a landscape gradient, understanding water processes and then soil processes. Some of these data are now being integrated into models to better understand the hydrology of watersheds in this area, and being able to understand what could be the impact of some of these alternative agricultural systems under, now with climate change, potentially the idea that we could reward farmers for greater carbon sequestration in these systems. We answered a lot of basic questions in addition to kind of looking at the potential to transform. And then looking at the economics of the system. Like I said, not every acre is created equal. And in this case, we've looked at which areas of the state are less profitable for corn and soybean farming. If you were to try to look at transforming agriculture, the places where it's less profitable, these townships with the hatched areas, whole townships of them, those would be the places that you would want to start. For example, if you really wanted to transition to alternative crops. So in informing that. And we're working with a partner, in this case, the University of Iowa. This is my colleague Ingrid Anderson from the University of Iowa. They have a mandate there to replace 40% of their coal consumption by 2020. They're well on their way to do that. And by replacing coal with biomass, what they're doing is they're also committing to spending $10 million per year around Iowa City, rather than shipping that local money out to places like Montana and Colorado to buy coal. So for them, it's not only about reducing their carbon footprint, but also spending more Iowa money locally and investing in local farmers. And here we are at DOE talking about, just last month, talking about our project there. So lots of cool ideas. How do we scale it up? Everybody knows money would help, right? Certainly the money for projects would not hurt, but in our work with agricultural stakeholders, everybody said, money is not going to do it. It's more than that. What we really need is more, people at that field, at that farm scale, individual farmers or landowners that are willing to take chances, to try something new, to work with it for a while, to figure out how they can integrate it in their farm. And the state of Iowa, under our statewide nutrient reduction strategy, we've asked every farmer to try one thing, try one new thing on their farm. And so by doing that, we all can learn about how to tweak, adapt, transform agriculture. The second thing is we need more information sharing, like what we saw farmer to farmer, peer learning in the Boone, like what we're now doing in the STRIPS project by providing some social support for our early adopters by connecting them to other farmers across the state that are doing the same thing. having each other answer each other's questions and support each other, because the idea of putting prairie in corn and soybean fields is very novel and antithetical to at least some Iowa farmers. They need support. So fostering more of these landscape community scale learning efforts is really key in moving forward. And certainly in Des Moines, with our change agents, we need them to be advocating for these kind of changes, and consistently so. And especially when it comes to that vision of 16% perennial, which just seems to be something of a consensus vision moving forward. You know, the alignment of policies we needed to get there. The idea of having potentially urban areas pay for environmental benefits upstream. We need new policies in order to actually achieve that, and we need our policymakers to respond with the policy instruments in order to do it. In general, tweak, adapt, transform, it takes people, right? It takes people, and I've showed you 3 examples of people trying new things, being innovators, experimenting. And these are just 3 examples of a multitude of people making these changes. And of course, I shared a story of Iowa. But as I travel the nation and talk with more and more people who are working in agriculture, there's examples of these all over the U.S. And so I find lots of reasons for great optimism moving forward. So how can you help? What can you do? And this is kind of in the wrap-up session of the talk. I have 3 things for you. One, so you've been here tonight. You are obviously interested at least a little bit in agriculture. Share your knowledge. I think one of the really key things that we need to do to move forward is we all eat, right? We're all around the supper table. We need to have more conversations about our food systems and our agricultural systems that support it at that supper table. So you've been here tonight. Share what you learned with your family, your friends, so that we can develop a greater understanding. The second thing is, visit the countryside. One of the challenges I think oftentimes with moving agriculture forward is the fact that we have separated urban consumers and rural producers. And one of the things I've learned in my research is that some things that I didn't think made a lot of sense, once I went out on the farm and I walked the field with the farmer and we talked about the decision-making process, it became completely rational to me. And I think that having these kind of conversations among people that are food producers and food consumers is really critical in terms of moving forward and understanding that we can agree on basic values and figure out ways that we can move forward in terms of practices. And the last thing I offer is that we need to advocate for more blended agricultural policies. The history of our agricultural policies has been really focused on yield production. And in the 21st century, we not only need yield, but we also need these environmental services. We not only need food, feed, fiber, and fuel as we stay on the Iowa State campus, but we also need clean water. We also need abundant wildlife. We also need beautiful places that create wonder. And we need blended policies, agricultural policies, if we're going to get to these landscapes that can produce both of those sets of values. So both the F's and the W's, food, feed, fiber, fuel, clean water, wildlife, and wonder. So central Iowa, this is what it looks like, 45,000 foot view. This is where I come from and am doing my work. And while I've shared this with you, the story about Iowa agriculture, realize that there's a global context to this. As you look at our major agricultural regions worldwide, from that 40,000 foot, 5,000 foot, they don't really look all that different, even here in Cache Valley. And if we are to create an agriculture, grow an agriculture that helps to sustain us and our beautiful blue planet, we need to all engage in these issues. So the last thing I'll ask you to do is get to work. That's it. So, yeah.
I guess I'm curious, what are some specific policies that you would advocate for in Iowa?
Yeah. Well, as a state employee and a scientist, I don't advocate, but I offer input on what the possibilities are. And certainly in my work, what I've been trying to do is represent what farmers are telling me what they need to sort of free up their decision space and allow them to be more flexible on their farms and have more heterogeneous management systems. One of the things in particular is that our current agricultural technology systems are geared up very well to support corn and soybean production, but it's really hard to do conservation. It's a real challenge to try to integrate in some of these conservation measures in the farm and actually qualify for some of the federal programs. So one of the things they ask for regularly is more flexibility in the federal conservation programs, and certainly less paperwork when it comes to signing up for them. That would be one thing. There's a whole bunch more, but yeah. Anything else? Yeah, back here.
One of the quotes from the farmer early on in your talk was that 2%, minimal grasses and stuff isn't really sustainable. And that would seem to me he was maybe talking about crop rotation, so you put things in prairie for a while, for a number of years, and then rotate it back into crops. Is that feasible or logical, or does that sort of system work?
Yeah, so in general, farmers don't like to talk about longer term crop rotations in Iowa. There certainly are some farmers that are doing it and making it work very well. In general, people aren't really open to 4 or 5 year crop rotations. It's just so easy. We've made it so easy to farm corn and soybean, and that takes a lot more labor in particular to do crop rotations. With the prairie strips practice, however, one of the questions I always get when I present to farmer audiences is, how long do I need to leave the prairie strips in place before I can move them and start farming that area under it? So they already, know. We know when we pull out ground out of the Conservation Reserve Program that we get yield boosts after we do that. And so farmers just intuitively know that, but they're wondering how long it will be before they can start to reap that benefit. And it's one of these things, it's like, we don't have the answer for you today, but we'll help you learn it, right? But they are definitely seeing prairie strips as a sort of a longer term rotation within their, 1 or 2 year rotation system. That's one thing that definitely perks them up, because they know it's going to provide, they know they're going to build better soils underneath that, and they also want to capture the soil that has run off from their uphill, egg field, and they also want to capture the nutrients that they know have also been captured in there. So we are hoping to, both study the soil system, but also the economics of doing that kind of longer term rotation within the field. Great.
You might have just answered this question, but I was curious earlier where you had those kind of water catchments, and you showed that these prairie strips are capturing a lot of the soil and the nutrients, and even some of that water.
Mm-hmm.
Well, it seems to me that you kind of have your corn, and then your prairie strip, and then your little catchment thing. Is it the case that, the prairies are, these prairie strips are helping to keep the soil there, but they're actually just kind of stealing it from the actual crop field? I mean, like it's all running off of the cornfield and just getting stuck in the prairie strip, which is great for the prairies, but maybe not for the corn.
Right. So we're comparing everything to, in that case, to a no-till corn, soybean, all whole field in that condition. And so the farmer would be losing that soil anyway, without the prairie strips. with the prairie strips, it allows them to capture it and then potentially at some point in the future, benefit from capturing that soil rather than having it leave the field, basically. And when I talk about this with farmers, I always say, with those upfield prairie strips, think about those as speed bumps, right? You're slowing down the water, allowing some of that soil to drop out. There's interaction between the water and the perennial plants. You're capturing some of that nitrogen and the phosphorus there. But at the end, we always have a prairie strip at the edge of the field, and the idea is we're going to capture those nutrients, that water, that soil in the edge of the field before it leaves and then has a negative effect on downstream ecosystems. Yeah.
I wonder if you've been able to identify any particular demographic that's more likely to implement prairie strips. I'm thinking about organic farmers, like more amenable to the idea.
Right. So we do have a couple of the 25. We have 2 organic farmers that have adopted, and their reason is largely for the soil conservation benefit. Because they're organic, they have to maintain cultivation as an option for weed control. They can't fully adopt no-till systems, so they're really concerned about soil loss and building soils. They're also interested in potential, with the pollinators that are attracted to the prairie strips, whether they could get a yield benefit from those pollination services. We'll, work to figure out if we can actually show that there's an economic benefit to that. We don't right now. But in terms of demographics, we have some absentee landowners that, live in Chicago, and, we have some, the city of Cedar Rapids is dealing with water quality and flooding issues, and so they've encouraged the airport in Cedar Rapids to adopt prairie strips because they want to be able to show upstream farmers that this is actually possible. So on city property, in that case, we're doing it on city property. Most of them are just private individual farmers that are interested in the long-term legacy value of the practice. That's a family farm, multi-generational. They want to keep it in the family farm, and oftentimes they have the goal of actually improving the soil quality for their sons or daughters or niece or nephew in comparison to what they inherited from their parents. So, and it can be, a 75-year-old or it could be a 30-year-old. So it's a really diverse group, which I think is really fun. Yeah.
In the scaling up department, have you looked at how much of these conservation actions would take to meet clean water standards or anything like that? And I'm interested in particular whether you think volunteer actions would be sufficient, and if not, how much would it cost?
Right. So in Iowa, we have a statewide nutrient reduction strategy to try to get the state in compliance with the Clean Water Act. And the goal is 45% reduction in phosphorus and 45% reduction in nitrogen that's getting into our surface waters. Of that, 41% of the nitrogen needs to, be retained within the agricultural system, and 6% of that phosphorus needs to be retained in ag. The other is the urban component. So we do have numerical goals as a state, and it's estimated that it would cost about $1 billion to actually do to actually achieve those goals.
And a large amount of that would be paying for land that would go out of production.
Yeah. Under the nutrient reduction strategy, we've looked at basically all the different practices farmers can use to retain nitrogen and phosphorus on their land, with the idea that we're building a toolbox here, and no one practice, fits every farmer, fits every field. Certainly, the ones that farmers are most interested in right now are the 4 R's, the nutrient management. They are also very interested in the edge of field practices that don't take land out of production, but we also know that those practices don't have the biggest bang for for the buck. In order to actually achieve the goals, we need to start converting some of the land back into perennials. It's just a function of, when you cover 75% of a state in one of two plants, and those two plants are only active for, less than half the year, you're going to have environmental consequences. And so at some point we have to talk about strategically integrating in perennials. The question is, which perennials, where are you going to put them, and how much do we need? So, yeah.
Well, thanks again. Thank Lisa again.
Thanks for coming out on Wednesday night. Great questions.